All right, hello everyone, this is Mr. Crozier. I'm going to go over our polar graph project for you. I'm going to show you some help on this, give you some help here. All right, first off, our job is to graph these functions here, and there's a whole bunch of them, and they are more difficult as you go down. So we're going to start off with one of this easy equation here, and we're going to graph this equation. Well, these are in polar graphs. It is not in rectangular. You are used to graphing points like 3, 4, which means you go over 3 and you go up 4, over 3, up 4, and you get to that spot right there. However, we can graph them as a polar graph, polar coordinates. And in this case, what we're going to talk about is we're going to talk about the angle to that value and the radius to that value. So we're going to talk about the same thing here. How far of a turn is it, and how far out do I go? The same thing. Instead of going over 3, 4, we're going to go up. Let's see what that angle is right here. If I put it in degrees and I go inverse tangent of 4/3, well, that's a 53-degree angle. So it's a 53-degree angle, and it's a 3, 4, 5 triangle. So if I go 53 degrees and I go 5, that will get me in the same spot. So it's just the idea that we can plot points two different ways. Over 3, up 4, or at a 53-degree angle, a distance of 5. Same position, different ways to graph it. That's what we're doing in here. We're plotting points. All right, so let's get to the work. How do we plot this? Well, we need to make a table, and that's what I have here. For problem number 1, I have my equation, and I have this table of inputs 0 to 350, counting by tens, and I'm going to input all of these degrees into this equation. Well, first thing, let's make sure I'm in degrees. Good. And now let's go ahead and try the first one. 9 times cosine of 2 times 0 is 9. So that value goes there. And then I'm going to go ahead and do the same thing, but I'm going to insert a 1 and make it 9 times cosine of 2 times 10. And there's where I have an 8.5. I forgot to round this, 8.5. And now I'm going to do the same thing, but I'm going to make it times 20, 6.9. Then times 30, 4.5. Then times 4, 1.6. I'm going to continue this chart, and you will notice some patterns. In some of the easier graphs, you'll notice some clear patterns. It does go all the way down to 1.6, and then it goes back up, and it goes up and down, because that's what a cosine wave does, right? A cosine wave goes up and down the whole time. So have the patterns there. I recommend you check them every time. Don't just assume that the pattern's going to be there. As the graphs get harder, it does change. So we have a table of points. Now what we're going to do is take those table of points, we're going to plot them on a polar graph. Instead of a rectangular grid for our graph, now we have a polar graph. All right, so how does this work? Well, we do two things. First is we do the degrees. I'm going to start here at the origin. As always, this is the origin, and I'm going to go towards 0 degrees, and I'm going to go out to the 9. Well, first thing you want to do is you want to label all of these degrees. It's divided nicely by 10, 10, 20, 30, 40, 50, 60, 70, 80, 90, very nicely. And the rings, there are 9 rings if you count them. This is the beginning. There's the first ring, second ring, third ring, fourth, fifth, sixth, seventh, eighth, ninth, all the way there. So you can't just count the rings. And then we're going to go from start to 0 degrees out to the 9th radius, the 9th ring. The next point says 10 degrees, but it only says 8.5. So I'm going to go on the 10 line, but I'm only going to go out to 8.5, and that'd be right there because this is the 8th ring, and that's the 9th ring, 6th ring, 7th ring, 8th ring, 9th ring. All right, on the 20 ring, it's out to, or on the 20 angle, it's out to 6.9, which is right there before 7. Make your points nice and big so they stand out. 30 is 4.5, 3, 4, 5, 4.5. And 40 is 1.6. There's 0, 1, 2, 1.6 is about right here. All right, so you can see that part of the ring right there. I guess I should have showed you what the entire graph's going to look like. If you do graph this correctly and you graph all 36 points, you're going to get this nice shape right here. Looks like a four-leaf clover, and there's my points. They go down this way, then there's another ring and another ring, but we're going to plot them around the circle. Now you can also do this on your graphing calculator or Desmos if you don't have one. If you hit mode and put your graph in, actually I want to put it in radians for this one, but if you put it in polar graph right here, and you type in the equation r equals this, and if you hit graph, it will show you the points being graphed, and that's the pattern it follows. It goes around, it spins around, it gets back to there. I'll do that again. If you graph it, this first part, I'm going to make it a little bit slower here. Well, no, that's fine. If you graph this, there's that first part, and then the graph goes down here. Then it goes here, then it goes up there. So we're going to go ahead and graph that going down there. But to get to this, the way you need to look at this is this next point is 50, negative 1.6. So I'm going to aim from the beginning out to 50. However, I'm not going to go forwards. I'm going to go backwards. So 50, if I go straight back from 50, that would be to 230 degrees, right? Because that's 180 degrees. So I'm going to go backwards, negative 1, negative 2. I'm going to go back to negative 1.6. And the next point is 60, negative 4.5. So there's 60. And straight across from 60, that would line up with 240. I'm going to go back. If I count forward, that's 1, 2, 3, 4, 5, 6, 7, 8, 9. If I go backward, that's negative 1, negative 2, negative 3, negative 4, negative 4.5. And then at 70, it's negative 6.9. So that is negative 1, 2, 3, 4, 5, 6, 7, right before 7. And the next one, 80, is negative 8.5. Well, right across from 80, that's what, 260, this was 250, this is 270, and straight across from 80 is 8.5, about right there. And then where am I at 270? Negative 9, well that's right there. So you can see this graph loops around this way. It loops up, touches, loops down here, and then you know what's going to happen. It's going to loop back this way. Now don't just guess where these are. Take the time to count them out so they're in the right spot, so it makes a nice, neat, symmetrical graph. And it will be symmetrical, so you can use that to help you ensure that the points are in the right spot. But again, let's go ahead and look at this graph one more time. The pattern was I went here, then I went down this way, then I'm going to loop back around that, and you'll see that in the graph. When you hit graph, it loops down, it goes back up, and it goes this way. And then what happens when it gets there? Well, it goes through the whole flower loop again. So just like a cosine wave goes up and down forever, this goes around this flower shape forever. All right, and that's what you would do. Continue, graph all 36 points, get a shape like that. Some of the other ones that are a little bit more challenging, once you get to some of these, let's see if we can't graph this one. What would that look like? 7 cosine of 4 theta plus 2 has some different patterns, some longer ones and some shorter ones there. So that's your graph there. Just be careful when you're graphing them all. And then when you get down to the bottom down here, these ones are a little bit more difficult. If you take a look at this one, number 7 here, it says change the domain 0 to 720. So what you're going to have to do on yours is it takes up to 720. So when this is 350, you're going to have to use both charts, and this is going to be 360. And this is going to be 370. And this is going to be 380. And you're going to have 2 sets of points. You're going to have 72 points. It's going to take 72 points to graph a clear picture of this one. And you can graph this one and this one. I think this one may show up on this calculator nicely. Let's try that. 9 sine of theta divided by 2. Has a graph here. Comes this way. And can make it go. I think I can make it, let's make it go to 13 and hit graph. This one, if it only goes around the circle once, you're here, but the second time around the circle, you pick up all of those, that side over there. So that's why you have to go around 720. Let me put that in degrees for you and I'll show you. Well, it doesn't change that, so we'll leave it in radians. This calculator needs radians, but once around the circle gets you all the way to there, and then if you go around the circle twice, you get the other side. And on these ones here, number 8, scale your graph by 0.5. So all of these loops, instead of being 1, 2, 3, 4, 5, the loops are 0.51, 1.52, 2.53, 3.54, 4.5, and that'll just a little bit more challenging. You can also look up on the internet. You can find some of your own equations. Plot them here. All right, you can graph them at Desmos. If you put this equation in here, this will give you the outer ring around your graph when you look at it on Desmos, and use this scale. And as you get down, they are more difficult. The easier ones are at the top. All right, hope this helps with your project.